Welcome sa ating data structure and algorithm. Part 1 tayo ng Prelim. So today we're going to discuss the following topic: data structures overview, environment setup, and also the algorithm basics for the part 1. Itong tatlo. And for the part 2, okay, sa next video natin, video lesson, we will discuss the asymptotic analysis, greedy algorithms, and divide and conquer. So let's go now with the data structures overview. Ano ba yung sinasabing data structure? No? So separately, i-define natin. No? So dito muna tayo sa structure. No? Data structures are the programmatic way of storing data so that data can be used efficiently. Almost every enterprise application uses various types of data structure in one way or other way. This tutorial will give you a great understanding on data structure concepts which are needed to understand the applications and the needed algorithms or the data structures format. So first is the definition of data structure is a systematic way of organized data in order to use efficiently, no? Sabi natin yan kanina, no? At may dalawa tayong internal part nun, no? Number one is the interface and second one is the implementation, no? Pag sinabing interface, ito yung naka-front, no, dun sa user. So each data structure has an interface, no? This is used by the system, no, to coordinate or to communicate with the user. So interface represents the set of operations that the data structure supports. An interface only provides the list of supported operations, type of parameters they can accept, and return type of this operation. So sa likod nito, nandun yung implementation, no? Nandun yung implementation, which provides the internal representation of a data structure. Implementation also provides the definition of the algorithms used in the operations of the data structure. This is the tools that makes the user, no, or the system usable, no, for the user. So nandito yung mag-update tayo, mag-reread, mag-access ng data, yung commands na para mag-delete, okay? O kaya mag-update ng mga records. Ito yung tinatawag na implementation. While the interface is the tools that communicates with the user, no? At itong implementation nasa likod siya ng interface, no? Para magamit ni user yung system, he needs, no, the interface and as well as the implementation. Now there are three characteristics of a data structure. Number one is correctness. Second one is time complexity. The third one is space complexity. Ano yung correctness? The data structure implementation should implement its interface correctly. Okay, so maganda dapat ang pagkaka-design. May mga controls. Yan, isa yan sa mga definition or kasama sa requirements, no, para maging correct ang ating system, no? Isa yan sa characteristics. Ano naman yung time complexity? Running time or execution time operations of data structure must be as small as possible. So dapat mabilis, no? The less time consumed, no, upon execution or on execution of a command or less time processing of information, then the the more efficient is the system, no? Space complexity, the memory usage of a data structure operation should be as little as possible. So, as much as possible, dapat yung mga input or yung mga information na sinisave sa loob ng system, dapat ay konti lang yung space, no? Or konti lang yung memory na ginagamit, no? So, those are the three characteristics of a data structure, no? Correctness, time complexity, and space complexity. Ano yung reason, no? Bakit pinag-aaralan natin ang data structure at bakit kailangan natin ng data structure, no? Number one is data search. Consider an inventory of 1 million items of a store. If application is to search an item, it has to search item in 1 million times or within the 1 million items. Every time, slowing down the search, no? As data grows, search will become slower. So ito yung reason, no? So the problem of data structure, the problem of data structure is how to manage data efficiently, which is ang isang characteristics ng data they grow, no? Daily, they grow. So, upon searching, it will become slower. Second, we have the processor speed. The processor speed, although being very high, falls limited if data grows to billion records. Yan. Hindi madali magpabilis ng processor. So, yung lumalabas na i7, i5, i3, ay matatagalan pa yan, no? Bago lumabas yung mas mabilis sa kanila na family of processor. No? Third, we have the multiple requests. As thousands of users can search data simultaneously on a web server, even a very faster server fails while searching the data. Yun. Isa pang reason, no? Which is very obvious at nakita natin yan. No? Parami ng parami ang nagse-search ng information online. Okay? Dati, matatanda, hindi marunong gumamit. Ngayon, marunong na rin silang gumamit. No? So, pati yung mga bata, dati limited yung kanilang gamit. Ngayon, dahil sa dami ng information, no, ay pati mga bata marunong na ngayong gumamit ng cellphone, gumamit ng tab, nagko-computer na rin sila. So, yung multiple requests, meaning yung sabay-sabay na pag-access sa isang information ay araw-araw nangyayari, no? So, the more the multiple requests increase, then the more we need, no, the a better way, no, to structure the data properly. To solve our problems, data structures come to rescue. Data can be organized in a data structure in such a way that all items may be required or may not be required to be searched, and required data can be searched almost instantly. Yan. So yung problem ng data structure is the ideal search is not to search, but for the data to be instantly available. Next, we have the three cases, no, for the execution time. Sabi natin kanina, napakalaga o isa sa characteristics ng data structure is time complexity, no, yung pagtitipid sa oras. So, with regards to that, no, we have three execution time cases. Gaano kabilis, ano yung classification, no, ng bilis ng bawat system, no? May system na mabagal, may system na mabilis, no? So ano yung kanilang category, no, or classification. Number one is the worst case. Ito yung pinakamabagal na processing ng isang information, no? Kapag yung computer mo or device mo nag-ahang, yan, nasa worst case scenario siya, no? So this is the scenario where a particular data structure operation takes maximum time. Yan. Naglo-loop na siya, no? Nakalagay sa screen yan, nagpaikot-ikot lang siya. Okay? Nakalagay sa ilalim, waiting. Yan. Waiting ka na lang ng waiting. So that is in a worst case scenario. Average case, this is the scenario depicting the average execution time of an operation of a data structure. If operation takes Fn time in execution, then M operations will take MF N, no? Time. So, yung F dito is a variable, no? To represent the system, no? And the N is the number of, represents the number of information, no? So, kung sa loob ng database, sa memory, meron kang halimbawa 1 million data. So, ang N mo is, ang value niya ay 1 million, no? So, yung F, yung system, or whatever kung anong inaan ng variable, pwedeng maging time yan, or pwedeng maging isang procedure or execution, no? So, kung gaano kabilis yun, this term or this symbol, no? Itong dalawang symbol na ito nagre-represent ng kanilang speed. Okay? Kapag average daw, we have an MFN, no? Okay? Sa best case naman, this is the scenario depicting the least possible execution time of an operation of a data structure. If an operation takes Fn time in execution, then actual operation may take time as a random number, which would be maximum as Fn. So, Fn is equal to Fn. Yan. So, kung worst case, the operation takes more than Fn time. Okay? Basic terminology, we have data. Pag sinabing data, data the values or set of values. So ito yung mga, for example, no, mga personal information na ini-input natin sa ating account o sa ating system, no? kung ano man yung system na gamit natin. Next, we have the data item. The data item refers to a single unit of values. For example, your first name, no? Data item yun. Your age, data item, no? Sa group items naman, data items that are divided into sub-items are called as group items. For example, yung name mo, dinivide natin sa tatlo. First name, last name, middle name. Okay? So, group items sila under ng isang category na name, no? Pag sinabing elementary items, that item that cannot be divided are called as elementary items. Okay? So, kung di na ma-divide yon, yung yung mga items na nasa loob ng group items, then they are called elementary items, no? For example, no, yung ang isang address, no? Actually, ang address ay group item 'yun, no? Kasi merong street number, no? Street name, okay? Merong city, merong building, okay? So, ang isang address ay maglalaman ng maraming elementary items. That's why ang tawag sa kanya, it is considered as a group item, no? Pag elementary item o yung street number, hindi mo na pwedeng i-divide yon, no, into several items, no? Kasi yun na yung pinakamaliit na information about the street number. Attribute and entity is that which contains certain attribute or properties, no? Which may be assigned value. So, merong lahat ng mga items sa isang information, merong attribute, no? At lahat ng entity yan, merong attribute din, no? So, entity, pag sinabing entity, it is an object which have its own attributes, no? So, entity set, entities of similar attributes form an entity set. So, kung ang dalawang object, no, sa loob ng system, magkapareho ng laman, so they are entity set. Okay, pareho ng attributes. For example, meron kang table, meron kang file, ang pangalan ay student's main file. Tapos may isa ka pang na ang attributes naman ay class section file. Okay, so naglalaman din yun ng mga students. So, they are called the entity set, no? Pareho silang table. Field name or a field is a single elementary unit of information representing an attribute of an entity. So, pag sinabing field, no? Ang isa kasing database or file ay pwede mong i-represent as parang Excel table. Okay? Parang matrix siya. So, meron siyang horizontal line, yan, yung horizontal information niya. At meron siyang mga column which is the vertical information. Okay? So, ganyan di ba ang Excel file, no? So, meron kang column A, B, C, D, so on and so forth. So, meron kang row 1, row 2, row 3, row 4. So, yung mga vertical information, okay? Ito, pag ganyan, pababa, those are called field, no? Field ang tawag sa kanya. Yan. And these are field name. Okay? So, mga field dito, yan, field. Yung horizontal information, those are called records, no? It is a collection of field values of a given entity. So, collection siya ng field values. So, ito yon. Okay, ito. Horizontal, yan. Okay? Yan. So, makikita mo dito na a horizontal or a record contains several field values. Okay? Yan. Field values. Ano yung file? Yung file na sinasabi, the whole, no? The whole collection of records, field and record, no? So, file is a collection of records of the entities in a given entity set. So, yung buong file, group of file and records na to, ang tawag dyan ay file. Okay, so we have the environment set up, but we're not going to do this, no? Wala naman tayong laboratory. So, but it is necessary if you're going to practice, no, the algorithm within a certain language, no? Kung yun ang purpose mo, you need a text editor, you need a C compiler, no? And those are called local environment setup, no? You need also the installation or to install the Unix or Linux if you're not using the Microsoft Windows. You can also use Mac OS or the Windows itself, no? and install the necessary system, no, or OS. We go now with the algorithms basics, no? So we already defined what is data structure. We will go now to the definition of algorithm. Algorithm is a step-by-step procedure which defines a set of instructions to be executed in certain order to get the desired output, no? So ang keyword natin dito ay procedure, no? Step by step. And also instructions, set of instructions. And then, itong order, no? It is executed in certain order. Okay? So, kung algorithm mo ay ibang, gumawa ka ng isang algorithm, no? Hindi siya pwedeng tumakbo simula sa baba or sa katapusan. Algorithm always starts with the first step. From data structure point of view, following are some important categories of algorithm. One, search, sort, insert, update, delete. These are the types of common algorithm, no, used in mainly, no, in all system, no. Lahat ng system may capability na mag-search, mayroong algorithm na mag-sort, mag-insert, mag-update at mag-delete. So ang meaning nito ay self-explanatory naman to, no. We're not going to define it, no. Characteristics of an algorithm, we have number one, unambiguous. Algorithm should be clear and ambiguous, no? So, hindi dapat daw siya confusing, no? Dapat simple and clear. And each of its steps, the phases, inputs and outputs should be clear and must lead only to one meaning. Ibig sabihin, one goal, no? One solution. Input, an algorithm should have zero or more well-defined input. So take note of the number zero. No? Output, an algorithm should have one or more well-defined output. So ma-notice nyo rito, pag sa input, pwedeng wala siyang input. But an algorithm cannot have a zero output. No? Always dapat meron siyang isang output. Next, we have the finiteness. Algorithm must terminate after a finite number of steps. So, kung meron ni-execute ang isang system, no, dapat yun ay magta-terminate, no? Dapat may katapusan, mayroong ending. Kapag hindi siya natapos, siya ay naglo-loop na, naghahang na yung system, no? So, an algorithm should not hang, no? It should have finiteness. Next, we have feasibility. Should be feasible with available resources. So, maganda nga yung algorithm mo, mabilis, pero yung mga materials at yung mga logic na kailangan ay hindi feasible, no? Or imposibleng gawin, then it cannot be considered as an algorithm, no? Independent, an algorithm should have a step-by-step direction. We should be dependent of any programming code. So kung may algorithm ka at ginawa mo lang yung para sa C language o kaya para sa Java language, ay hindi siya pwedeng i-considered as algorithm, no? Kasi dapat ang algorithm is independent of any programming code. How to write an algorithm? There are no well-defined standards for writing algorithms. Rather, it is a problem and resource dependent. No? Algorithms are never written to support a particular programming code. So, depende sa problem mo and sa resource na available sa iyo, no? Kung paano mo gagawin yung isang algorithm. As we know that all programming languages share basic code constructs like loops, do, for, while, and flow control, if, else. These common constructs can be used to write an algorithm. So, we write algorithms in step-by-step manner, but it is always the case. Algorithm writing is a process and is executed after the problem domain is well defined. So, number one steps is to define the problem. No? Ano ba yung problema na isosolve ng iyong algorithm? That is, we should know the problem domain first for which we are designing a solution. But technically, we have the following format, no? Sa pagde-design ng algorithm, no? We first start with the word start, no? Step 1. And then, itong lahat na nangyayari to, no, sa isang program, declare three integers, no? Declare variables, define variables, and then give them values. Define values of A and B, and then the next logic is to process them, add values, and then to output or to give the output, no, as a result of your algorithm. And then, one of the type of output is printing. So, print may also mean display on the screen. After that, sabi natin, di ba kanina, the algorithm must have an ending or a finiteness. So, we must end in a stop. Okay? So, yan yung basic flow ng isang algorithm. No? Lahat ng system may ganito. No? May declaration of variables, may definition of values, declaration of values, or tawag natin dyan sa programming ay initialization of values of variables, and then processing. Itong dalawa, processing, and then ito, output production. Okay? And then, terminate. So, lahat ng system ay ganyan. So, as an example, algorithms tell the programmers how to code the program. No? So, if you have an algorithm which have to solve the problem of two numbers, getting their sum, no, and displaying it, and this is the correct algorithm. No, we have start add, get values of A and B, meaning get from the user, and then step three, process, and then output, no, the display C command, and then terminate. Okay. So in writing the algorithm also is the step numbers, no, is optional, no? Pero mas maganda merong mga steps number para alam mo kung nasaan ka na, okay? Kung ito ay gagawan mo na ng code, mas magandang makita mo kung nasang number ka na, no? Ng steps, no? So we design algorithm to get solution of a given problem. A problem can be solved in more than one way. Ito yung maganda ring i-take note, no? Sa programming, maraming ways, no? Sa pagdi-design ng algorithm, no? Maraming klase ng algorithm na nagso-solve ng isang type ng problem. Okay? So we can have multiple solution, no, for one problem. So solution 1, solution 2, solution 3, solution 4, but they have a different performance. So maybe yung solution 1 medyo nagbibigay ng tamang result but medyo mabagal, no? Sobrang mabagal. So si solution 2, pwedeng mabilis siya but inaccurate naman on some part of the result, no? So may mga ganong instances. So ang pipiliin natin is the one which have the most, no, most number of positive output, no. For example, sa solution 3, hindi lang siya nagtitipid ng memory space, mabilis din siyang magtipid ng mabilis din siya mag-process ng information, mabilis mag-output ng data. Then, sa solution 3, yung most, no, efficient na solution. We go now with algorithm analysis. We have two types. Number one is a priori analysis. This is a theoretical analysis of an algorithm. So kung meron kang ginawang algorithm, ang next step mo is to test it, no? To analyze the result, no? Kung mabilis ba siya o mabagal o katulad ng ginawa natin dito, no? Para malaman natin kung ano yung kanyang negative o yung strength at weaknesses niya, no? So, ang isang type nun para malaman natin yung para ma-analyze natin, no, yung performance ng ating algorithm is yung a priori analysis. This is theoretical, meaning hindi tayo magte-test, no? Iniisip lang natin, no? Ini-estimate, no? Efficiency of algorithm is measured by assuming that all other factors, processor speed, are constant and have no effect on implementation. The next is posterior analysis. This is empirical analysis of an algorithm. So dito na tayo nagte-test, no? So gumagawa tayo, kumukuha tayo ng mga test data at tinatry natin doon yung ating algorithm. Then, tsaka tayo magpo-formulate ng ating analysis. This is then executed on a target computer machine. No? In this analysis, actually statistics like running time and space required are collected. So, yun ang difference ng priori and a posterior analysis. So, we shall learn here a priori algorithm analysis. The algorithm analysis deals with the execution of or running time of various operations involved. Running time of an operation can be defined as a number of computer instructions executed per operation. So, yun ang tinatawag na running time. No? Yun yung number of computer instructions per operation. Algorithm complexity. Suppose X is an algorithm and N is the size of the input data, the time and space used by the algorithm. X are the two main factors which decide the efficiency of X. So ito yung dalawang factor na makakapag-decide no, dun sa ating analysis, whether it's priori or posterior. Number one is time factor. The time is measured by counting the number of key operations such as comparisons in sorting algorithm. No? So, gano'n siya kabilis mag-compare, mag-sort, mag-count. Okay? Sa space naman, the space is measured by counting the maximum memory space required by the algorithm. Yan. Malaki bang kailangan yung memory bago siya tumakbo ng maayos? That is space factor. No? The complexity of an algorithm Fn gives the running time and thus slash or storage space required by the algorithm in terms of an n as the size of input data. Space complexity of an algorithm represents the amount of memory space required by the algorithm in its life cycle. The space required by an algorithm is equal to the sum of the following two components. Number one, we have the fixed part. Number two, we have the variable part. So sa fixed part, dito natin ini-store yung mga data and variables that are independent of the size of the problem. For example, simple variables and constant use. Ito yung mga information na internal no, na ginagamit ng system. Sa variable part naman, ito yung mga information na ginagamit sa, for example, sa pag-compute ng age or grade or amount. No? So ito yung mga dito ini-store no, sa variable part. No? Yung ginagamit sa computation. No? Para makapaglabas siya ng tamang output. Yung fixed part naman, dito natin nilalagay yung mga metadata o internal data na information na ginagamit ng system. Okay? So wag kayong don't be confused no with space factor and space complexity no magkaiba sila. So ito the space is measured no by counting the maximum memory space. So ito yung factor na nagme-measure no under ng space factor no mine-measure natin yung space. Sa space complexity it is the representation of the amount of memory space. Okay? Ito yung sumusukat no dito natin sinusukat. Ito naman yung nagre-represent nung amount ng sinukat natin, no? Amount of memory space. And the space complexity is part of the algorithm complexity. Example, space complexity SP of an algorithm P is SP is equal to C plus SPI, where C is the fixed part and SI is the variable part of the algorithm, which depends on the instance characteristics I. Following is a simple example that tries to explain the concept. No? For example, we have the algorithm sum. So we will take the sum of two variables, A and B. So we write start, and then step 2, we process. C is equal to A plus B plus 10. And after processing, we output C, and then we stop. Here we have three variables, A, B, C, and one constant. No? Hence, SP is equal to 1 plus 3 equals 4. No? Now, space depends on data types of given variables and constant types, and it will be multiplied accordingly. So, si 10, saan ini-store? Sa fixed part. No? Si variable sa variable part. Time complexity of an algorithm represents the amount of time required by the algorithm to run to completion. Time requirements can be defined as a numerical function, Tn. Again, si Tn ay time, and then Cn is the number of your information na pinaprocess, where Tn can be measured as the number of steps, provided each step consumes constant time. For example, addition of two n-bit integers takes in n steps. Consequently, the total computational time is Tn equals C times n, where C is the time taken for addition of 2 bits. Here we observe that the Tn grows linearly as input size increases. So that's it for our data structure algorithm prelim part 1.